Howdy everyone, my name is Darshil Rajada and today I'll be presenting milestone 5 of our AetherMart data management project. This milestone focus on something extremely relevant in modern enterprise systems, like how companies involve their data strategy when the business grows faster than the old database architecture which can support, right? The system and the theme today is hybrid data architecture and NoSQL integration. What you'll see is not just a technical implementation, but real world business transformation story. Like the companies like Amazon, Uber, Walmart, Netflix all went through the similar transitions. And today I'll show how Ethermart applies the same principle and yeah, we'll understand hybrid systems are now the norm and how NoSQL fits into the architecture and what the business gains from these transformations. Okay. So AetherMart is an e-commerce company, just to revise, that has been growing quickly. With this growth come a huge explosion of data from multiple channels, right? The website browsing, clickstream logs, mobile app events, IoT start, home telemetry from integrated products, customer reviews, social media comments, customer support chat logs. So on this database, MariaDB is great for structured transactional data like orders, products, and inventory, right? But it starts breaking down when we try to store unstructured or semi-structured data. Okay, for an example, if customer writes a product review with a text, image, metadata, sentiments, score, traditional table become an extremely rigid, right? So in real world, like let's say Walmart faced this exact challenge around 2013 when clickstream data exceeded 240 million entries per hour. That traditional systems couldn't handle the volume and variety, which led them to adopt Hadoop, NoSQL stores, and S3 data lakes. So yeah, Ethermart in today will gonna see the same, the turning point, which facing slow insights, data slots, incomplete customer handling, and limited personalizations, right? So let's first understand what is data lakes versus data warehouse, right? So to design a modern architecture, we first compare data warehouse and data lakes because both play very different roles. Okay. Data warehouse, which enforces schema on write, that means data must be cleaned, structured, and validated before loading. They are perfect for, like analytics, BI dashboard, finance reporting, and stable analytics, right? But the data lakes stores raw data in at any form like JSON, CSV, images, logo, audio, telemetry using schema on read. That means we decide on structure only when we analyze it. These two systems are complementary. Like Netflix uses Amazon S3 as it raw data lake for storing billions of events per day from user sessions, streaming performances, and device logs. But it uses Snowflake and Redshift for business intelligence dashboards. So Ethermart needs both. All raw logs and IoT data go into the data lake, while curated and structured data goes into relational tables. So this duality ensures that cost efficiency, flexibility, and long-term scalability. Okay. So why we need an hybrid data architecture? So hybrid architecture means we combine multiple storage technologies, each designed for a specific type of data. Okay. In Ethermat's case, web app and IoT events flow into an S3 data lake. Structured transactional data stays in MariaDB, and an unstructured or semi-structured document like reviews, customer profiles go into MongoDB. Okay, this approach is solves number of real business pain points. So we no longer force everything into SQL tables. We reduce ETL complexity. We eliminate data silos as well, and we increase insight speed. Okay, and in if I want to explain by example, Uber is the perfect one. Like Uber uses MySQL for trips and payments, Cassandra for GPS telemetry, MongoDB for geospatial data, and S3 for long-term analytics. So they didn't choose one database, but they choose the right database for each job. And Ethermart is doing the same thing. Okay. So this is what the hybrid architecture explain, and that's what I mentioned, that from web app or IoT sources, it comes into S3 bucket, then ETL or ELT pipeline it goes through, loading and transformation happens. It goes to MariaDB cluster, products order, and review profiles will go to MongoDB EC2, right? And then analytics or BI tools, right? So NoSQL choice and justification MongoDB. So for the NoSQL layer, we selected MongoDB. And why? So because it stores JSON like documents, right? Very naturally. Customer profiles involves overtime MongoDB supports dynamic schema changes. About review and chat logs may have different fields for different customer, right? Python ETL integrations are very simple to do, and replica sets on EC2 give us also an high availability. And we evaluated, alternatives like Cassandra is excellent for high write workloads like logs, but not for nested documents. Neo4j is great for relationship heavy data, but not for text heavy content. So a perfect business analogy is Amazon.com. Like Amazon stores product reviews, question answer, metadata, and structured text in a document database because it preserves the natural shape of the user generated content. Okay, that same pattern applies closely to AetherMart as well. Okay. About proof of concept and implementation, before we, go just by PPT, I'll explain you the actual what I did in the AWS EC2 instance. So let's go over there. Okay. So let's start from the beginning. So first, as you can see, under the root user, sudo apt install via MongoDB org. So we install MongoDB, okay? All the packages has been installed, okay? And we checked MongoDB has been installed, like it's active and running, okay? So after starting the MongoDB, like we can see the status is up and running, okay? And after that, you can see I went to MariaDB just to check if MariaDB is also connected. I checked my database name, okay. Then I created a user, okay, with the password and the private IP address. Okay, we grant all the access to that user, okay. And then I have created a code, okay, and we to convert that data into MongoDB, okay. And you can see over here, I have created virtual environment, and in that virtual environment, we have created a Python file and we pasted that code over there, okay. So let's understand the code as well. I'll show you the code on the Visual Studio Code. Okay, so you can see the code is over here. So what I did basically is, like this is the code for data migration script, right? That transfer data from a MariaDB, which is MySQL database, to a MongoDB database. The functionality is basically that the script connects to a specific MariaDB database. It will read all of your data, perform necessary data type conversations, and then inserts this data as a document into, like a corresponding collection into a MongoDB database. So just to explain this in a summary, so you can see like configuration from here to here, right? It will set up a connection details for the MariaDB source, right? Including a user, password, host, and port, right? And database name. It will set up a connection detail for MongoDB destination, okay, which is Mongo config, specifying the host port name again and the new database to create AetherMart Mongo, okay. And then MariaDB connection and table discovery, okay, that which is from 29 to the line, uh, yeah, from here 30 to over here 42, okay. So it will gonna establish a connection to the MariaDB server using the configuration detail. It will fetch the list of table names from the source database, right, which is AetherMart in our case. Then from here to here, it will gonna establish a connection to the MongoDB server, select or create the destination database, which is AetherMart Mongo, okay. And after that, from here to the here it will gonna script the script will gonna iterate through each table found in MariaDB. Like data fetching, it will execute the select query to fetch all rows from the current MariaDB table. Data type cleaning, which is basically converts MariaDB's date object into Python date time object, right? Specifically at midnight because MongoDB prefers date time, right? It covers MariaDB's decimal object into standard Python float objects, which is MongoDB can store natively, okay? And about insert, that it selects the corresponding MongoDB collection. It clears an existing data from the collection using, and it also inserts the fetch and clean row into the MongoDB, okay? And after that, in the step number 6, like once the loop ends, both MariaDB and MongoDB connections are properly closed. A summary is printed, including the number of tables are migrated and the total number of documents are inserted, right? It is robust, except the blocks are included to catch and report connection, or operational errors, both MariaDB and MongoDB. Okay. So let's go back to the EC2 instance. So after that, you see like it set it up and then it started processing all the tables, customers, category, order items, products, reviews, and you can see over here like successfully inserted 40 documents and migration complete, successfully migrated 7 tables, and this is the number of documents have been inserted. Okay, so you can see like I tasted, so database it's showing AetherMart underscore Mongo. Okay, I see like show me a tables and it's showing me all the 7 tables. Okay, and after that, just to test, I have performed a CRUD operation, which is create, read, update, and delete. I'll show you the file and explain that as well. Sorry. So you can see over here, this code like is a sequence of MongoDB shell commands that demonstrate the basic CRUD operations on a collection name, which is product in our case. It walks us through the life cycle of a single data document. Okay. So this uses standard MongoDB commands to insert a new product, retrieve it again, modify the attribute, and finally remove as well from the database, which is the product collection. Okay. So first of all, create we did. So a new product, like a new document name, like something Lumos Vision, which is again GPT generated class, has been inserted into product collection. It initialized the field. Okay, like name, description, price, and automatically generated created timestamp. Okay, then about read. So the scripts immediately queries the database using a find one to retrieve and display the newly created Lumos Vision Pro Glasses document to confirm that it has been successfully inserted. Then about the update, okay, so the document has been modified based on the name. Okay, dollar set, which is the prices updated to the discounted value, and the stock level also automatically decremented by 10, like from 120 to 110. Okay, like simulating the cells. Okay, and then about read, so the product is retrieved again to verify that price is now 649.99 and the stock level is 110. Okay, and about delete, so we have permanently removed from the doc like the product collection. Okay, and then about read to verify delete, so the final query, this one attempts to find the product again. It should return null or empty, confirming the successful deletion of the product or document. Okay, in short, like it's a demonstration of how to manage a single record complete life cycle in MongoDB using essential commands. So on EC2 instance, so you can see like I have performed about create. So the same script we have inserted about the next generation AI classes, and you can see acknowledge true, insert object ID, which object has been inserted. Okay. Then over here you can see the find project to verify if it's created, which is read. So yeah, it says it has been created. Okay, and then the same, once you put the object ID, you'll able to see the description, price, category ID, created at which time and date. Then about the updation, so we can apply discount for a promotional event and reduce stock market, like stock, sorry, price after 10 units sold. So that's what have been done. Okay, and it says acknowledge true and match count to 1. Okay, and about the deletion, so like before deletion we're gonna check, so it says now it has been reduced. right? So we just read that to verify the update has been done successfully. Okay. And about the deletion, so remove the product from the database. So we have removed it, you can see. And again, we'll try to find the product again if like they should return either null or not. And you can see it is returning null. So yeah, that means it is working. Let's go back to PPT. Okay, so the proof of concept and implementation, that's what I shown you, right? That to prove the architecture works, I have built MongoDB 7.0 in Ubuntu EC2 instance, and then we enable configured the MongoDB instance, created read-only account and ETL operations. We created end-to-end ETL pipeline, and we validated all collections MongoDB using Mongoose, right? So yeah, that's what about the implementation part. And just to give an example, Airbnb uses a similar approach by replicating MySQL data into Elasticsearch and document stores for fast search and user-facing operations. And we are following proven industry architecture. Okay. About ETL script overview, which is I already explained, like ETL script was written in Python and handled several important conversation. MySQL date and timestamp fields were mapped into Python datetime object. Decimal converted to floats and empty tables were handled by gracefully to avoid crashes, right? Each table became its own MongoDB collection, and this resulted in clean JSON documents ready for analytics, experiments, or machine learning models, right? So this is the same design used by Stripe. Stripe replicates SQL data into JSON form for their, internal analytics platform, allowing wide experimentation and faster iteration, right? So yeah, that's what mentioned that results successfully implemented and data inserted as JSON documents. Okay. CRUD operations, again, I have shown you that how to insert new customer reviews, how to query based on star rating, sentiment, or product ID, how to update a customer profile with new attributes, how to delete or archive outdated information. Document database shine in this scenarios, right? A TripAdvisor, for example, stores millions of user reviews in a document store to enable fast keyword search, full text indexing and dynamic filtering. So the CRUD operations prove that the AetherMart can now query customer insight instantly without have a SQL joins. Okay. So about evaluation, so we evaluated across four major dimensions, which is scalability, flexibility, cost efficiency, and performance. So about scalability, MongoDB scales horizontally using sharding. S3 can scale nearly infinitely. Okay. About flexibility, so dynamic schema allows us to add new attributes like sentimental scores or IoT metadata without altering any SQL tables. Okay. Cost efficiency, so S3 provides extremely low cost storage for years of history, and MongoDB reduces the load on MariaDB, preventing the need for expensive scaling. Okay. So performance document based queries run faster for flexible dataset like reviews and chat logs, and target users uses nearly identical model like a mix of relational database S3 lakhs and NoSQL to support like omni-channel operations. And Ethermart now gains the same level of architecture maturity. So yeah, that's what mentioned that these are the strengths: scalability, flexibility, reduced load, and real-time insights. And challenges are data consistency, increased security, and complex ETL management. Security we will discuss. So security becomes more complex when multiple systems are involved, right? So we implemented several best practices, which is role-based access controls, different roles for MariaDB, MongoDB, and S3 access to, minimize privileges. TLS encryption, which again all data transfers between EC2 instance and databases are encrypted. Network segmentation, so we use VPC subnets and security groups to isolate MongoDB from public access. Audit logging, so we are enable logs in CloudWatch to track and access the patterns. And key rotation, so basically credential rotation prevents long-term exposure, like a Capital One use the exact layered approach to secure their multi-database cloud architecture. Okay. So, yeah, these are the key concerns: PII across multiple platforms, right? The personal information of each customer, access control of multiple database and data in transit, at rates protection. And this is the best practices we're gonna use or we had used. Business impact summary. So the business impact of the architecture are significant. Again, faster analytics that data scientists no longer wait for rigid SQL and ETL processes. This is can doable from 9 hours to 3 hours as well. Better customer understanding, it's basically we can now combine structured sales data with unstructured reviews, IoT behavior and clickstream logs to build a 360-degree customer view. Okay. A cost saving, obviously offloading heavy workloads to S3 prevents and SQL scaling cost, right? Then it also improves analytics response time by 40%. Okay. Future proofing, that the hybrid model allows AetherMart to add new data sources very easily, and this is the foundation needed for future personalization, recommendation engines, fraud detection, chatbot training, and predictive analytics as well. So yeah, it's strengthened our cross-system security compliance and prepared for AI-driven personalization as well. Okay. Lessons learned and AI usage disclosure, very important. So the projects taught me several things. I would say the importance of understanding of how SQL and NoSQL handle data differently, the challenge of mapping data types across databases, the value of hybrid architecture in modern enterprise systems, the benefit and limitation of using AI tools like GPT-5, Cloud, help with debugging and troubleshooting, but every output still required manual verification where you'll have to test it again and again. So most importantly, this milestone helped me to develop, like cloud deployment and cross-platform data engineering. So which is really helpful in data teams when you do internship or jobs in everyday life. Okay. So yeah, I use GPT-5 and cloud in some aspect as well. And yeah, this is the correction made, which decimal to float, obviously because of Python, and fixed data object migration to MongoDB. And yeah, handle empty data to prevent script crash, which I already told you. Okay, and human validation is necessary. Conclusion and future work. So to conclude, I would say the milestone demonstrate how Ethermart can successfully transition from a single database environment to a scalable hybrid architecture, combining the S3 for raw and semi-structured data, MariaDB for core relational systems, MongoDB for flexible document storage, and in the next phrases, which is upcoming milestone, we can also introduce Kafka for real-time streaming, Spark for distributed analytics, right? Machine learning models for intelligent recommendation and advanced Power BI dashboards. Also, we can build on hybrid data sources. Okay. So yeah, I mean, these are the all we can do in further in real time, uh, as far as the MongoDB is concerned. Okay. So yeah, thank you so much to listening to me, uh, for your time and attention. If you have any questions related to hybrid data architecture or specialized NoSQL integrations, feel free to reach out to me on darshil.vaijada@tamu.edu. Thank you so much once again. Gigam. Bye bye.